Welcome to the time machine. When I finally got the cabin top mounted about a week and a half, 2 weeks ago, I cut just this opening. Everything else was still covered, and just cut this opening big enough that I could crawl through. And I sat down inside of here, and it just had this wave of nostalgia wash over me. And it just reminded me of being a kid, like 9 years old, building tent forts with my friends out of all my mom's bed sheets in the house, and constructing between tables and creating our little forts for our adventures. And it just reminded me I'm sitting in this boat that I'm building for adventures. And the name came to me. I think we're going to call it Time Machine. But here's the inside of the cabin. It's very small, but this is a race boat. I wanted it all. I wanted all my room out in the cockpit, and so that's. I think my crew's going to like that too. So that's where we're putting all the accommodations, are outside. It's just slightly modified from quite a few of the other ones that are built. Most of them have seats that come into about here, about where my hand is. And I wanted to vary from that. I didn't like it because I sail on an Ultimate 20 quite a bit, and you can't quite get out on the rail of the boat because your calves hit up against the side here, and you're not able to sit out. I don't want to go too far here, but you're not able to sit out all the way to the rail. So oftentimes when your crew either has to swivel around to get his weight out, so to avoid that, I had my designer cut this down, and I wanted to make it as narrow as possible so that when we're comfortably sitting on the boat and sailing in almost any condition, our weight's already out there. Right here we have some carbon fiber. This is just a standard weave carbon fiber. I'm also using some unidirectional carbon fibers where the fiber orientation has to be a certain strength, which you pull out even one little strand of this stuff, it is just so strong you'd cut your hand open before you'd break the strands apart. It's just incredibly strong. That's why they're using it for sailboat masts, for bike frames, and all kinds of high-tech applications. It's really interesting. And then we go to S-glass, and this is a bunch of S-glass that I bought for this boat build that has an interesting story. This stuff was used on the NASA. I bought it secondhand from a doctor that was going to build an airplane with it, but he got a little bit older and it just didn't happen. But he had a friend that was a scientist that works for NASA. This was used in ballistic rockets, and was the fiberglass used to make the ballistic rockets. So I have that going into this boat, so it should sail like a rocket ship. Then we go to our third glass type that's being used on this build that you can see underneath this pill ply here, and this is just your standard regular old fiberglass. It's a 6-ounce E-glass, and it's used in almost every sailboat that's made out there. And it's just more of your utilitarian, really cheap in price. This stuff you can pick up for maybe $12 a yard. This goes up to about the S-glass. You're going to get comparative at about $32 to $38 a yard. And then you go up to your carbon fiber, which you can spend $50, $60 a yard for the materials. So you have to watch where you use it. I'd love to do this entire boat out of carbon fiber, but I don't have it in my budget. But I did buy this E-glass at such a bargain that it's going into most of the boat build. Is what I was trying for was the front of a 1957 Chevy. I just wanted that rounded, like their headlight cowl was. And that's what I was aiming for with the look of my bowsprit. So I've got a 6-foot long bowsprit that's going to come out of the front of this hole here. and it also articulates 24 degrees to each side, so it's going to be pretty hot setup. Well, here are my sailboat drawings, just some of them I keep up, basically what's pertinent to the build at the time that I'm able to come out here and just take a look at them while I'm working, and my hands are covered in epoxy because I keep my blueprints and designs upstairs, because you know, once you get this stuff all over it, it all falls apart. So I keep this stuff out here. Probably one of the funnest things that I'm working on, and I'm just enjoying it, is my asymmetric sail design. And other than maybe a catamaran or the trimarans that are racing, as far as I know, there's no asymmetric sport boats like this that are sailing in Colorado with a articulating bowsprit. And I spent a considerable amount of time on this with a engineer trying to get this thing optimized. The problem is there's so little information out there on this stuff. I mean, you maybe have a few hundred people in the world right now building boats like this. It's a real small community, so the information isn't always there. And so we've worked out this pole so it'll swing out and hug the sides of the hull frame and give me the most amount of articulation and allow me to effectively chase the wind. So I'm having a blast with that. But the problem is it's all just a learning curve trying to figure the stuff out. There's, like I said, not a lot of information out there. I'm also working on my kill design. We'll show you that here in a minute. And trying to get everything figured out on that. I've got 200 pounds of lead that I need to pour into a form that I'm making. Everything's a work in progress. So, you know, we're working on that as we continue. This here is the foil design. I was telling Randy about it just a little bit ago, that it's a NASA profile. It's a NACA 12 is what they call it, and it's an actual aerodynamic wing. This boat here is designed to plane in 8 knots of wind. We're limited going upwind just because it's a short boat, so you're limited on that upwind speed by waterline, but downwind, with those foils and the design of the boat, we're supposed to be able to plane in 8 knots. And so all these things are going to go into conjunction and play a part in making that happen, especially with the asymmetric pull. I think it's really going to give us some advantages that other boats just don't have, because this is relatively new technology. I was looking at how other people were building their kill and rudders, and they were doing them with planes and some of these guys were spending months on them. And I was trying to not reinvent the wheel, but trying to think of ways that I could easier do this. So I actually made these things on a table saw, and we did them to the NACA 12 profile we were talking about. And what I did was this ended up being a laminated piece. We alternated, of course, our pieces side for side, in for in, to change the grain pattern because it creates a stronger kill and rudder profile structurally. And so I laminated this all together, and so it was like a 2x12 piece of wood. And then ran them through the table saw, and I made full-length rips that the blade was set to the depth and also set to the width so that it would form this profile on the end, which is our aerodynamic NACA 12 wing profile. And I just simplified things by doing that. I was able to take my keel, take my rudder, make 4 cuts with the blade in each position. I was able to make 4 cuts, then change the blade height, width, and then make the next one. And then I took a hand plane to connect those dots in between. And I was able to construct what sometimes taken people months to do. I mean, they're spending weekends and nights and evenings and working on it continuously. I was able to construct in basically a Saturday. It took me, of course, longer. Like this has my coats of fiberglass on it, which we have that That S2 structural glass is on here. I've got 2 layers of that for the rudder. And then the keel, I've actually still got a little more woodwork to do on this, is I've got to dado this out, and it'll get inlaid 5 layers of carbon fiber, unidirectional carbon fiber, which is going to make this strong longitudinally, because the keel is going to have to support what this is just my foam mock-up that I'm not finished with. This is going to be 200 pounds of lead at the bottom of this keel structure. So that carbon fiber is going to be really important, because as the boat's heeled over, you're supporting quite a bit of lead, 200 pounds there, plus the force of the water and the sails above. That okay?